Hello and have a good day, everyone, especially to our panel and viewers of my presentation. I am Reminges Anak Ding, and my other team member is Joshua Anak Rivi from Polytechnic Kuching Sarawak. For Nricon 2022, our paper submission is entitled Dormitory Friendly Low Energy Dryer. The idea behind the innovation of this dryer came from a problem which is often experienced by the students of Polytechnic Kuching Sarawak, where they have difficulties in drying their clothes during rainy season. From previous observation, it is often that we can see the rain starts early in the morning and sometimes ends late in the evening. So these add the difficulties of drying clothes. Furthermore, the policy that has been set in the dormitory is only allowing students to have power restriction up to 250 watts of electricity consumption. And furthermore, the dormitory doesn't have any conventional dryers. So in this research, the dryer was designed to have the same function as a conventional dryer, but it has different design, material, and also the consumption is low, a bit of different with the operating procedure, which is based upon the air circulated light radiated heat conductivity method, which can be seen at the figure at the bottom of the slide. The main objective of the study is, of course, to determine the optimum number of heating elements and its assisting components, which can achieve maximum power consumption of 250 watts. In order to do this, the challenge is we have to determine the dimension, shape, and the capacity of the dryer since it is using low energy. Finally, the temperature, humidity, and duration of the drying process was assessed. The research have found that the limit of the capacity of this dryer is up to 3 kilograms, and it has consumed the maximum power of 250 watts, which can be used in Polytechnic Kuching Sarawak dormitory. The heating temperature achieved during the design element was able to reach 50 degrees Celsius within a drying time in the range of 45 to 60 minutes, which is comparable to ordinary dryers or conventional dryers out there, which is called the tumble dryer. The power consumption will be around 1,400 to 1,600 watts of power consumption that can achieve a drying time of 30 minutes. Before we go to the ideas of the method being used to develop this dryer, we go some of the theory behind heat and thermal. Okay, so thermal conductivity refers to the intrinsic ability of a material to transfer or conduct heat. Okay. There are three methods of heat transfer, which is being thermal conductivity itself, heat transfer, and convection and radiation. Thermal drying is a process of dehydration of moist product based on moisture evaporation by heating, which can be achieved in the normal dryers. Okay. A bit about the material being used during the study, which is incandescent bulbs. So incandescent bulbs emits light through the heating of small metallic coil called filament, surrounded by gases in vacuum that can achieve heat up to 2200 degrees Celsius. Okay? While providing plenty of light, they releases 90% of their energy as heat. Okay? This can be considered as a potential heating element. Steve Regekas also said that in his previous research that the surface temperature is going to be a mile of 70 degrees Fahrenheit or almost 24 degrees Celsius per bar if it is being used. The heat transfer in the light bulb takes place due to radiation, okay, because the conduction and convection require a material medium to transfer heat. So by using light bulbs alone, it is not efficient as it is. Okay? So we need a heat exchanger. A heat exchanger is common application where good thermal conductivity is important. Heat exchangers do their job by transferring heat to achieve heating. So in this research, we are considering a material that can act as heat exchangers to assist the heat transferred by the light bulb and then reflect it to the material to be dried. Many dryers out there consisted of a rotating drum called tumbler, which heated air of a minimum 60 degrees Celsius, heat for 30 minutes, is circulated to evaporate the moisture. Now we go to the materials being used during the research. So the innovation of this low energy cloth dryer consists of stationary housing, which can be seen in the video at the bottom of the slide. It comprises of a ventilation system to circulate air and components of heating, which is the light bulb. There are 10 units of 25 watts of incandescent light bulbs installed on the interior wall of the said housing. And of course, we have control installed within the said housing to switch on the power supply. Upon finding materials on literature review, we suggest that the inner linings of the wall are wrapped with aluminum foil, and the door are constructed with glass, which serve to promote thermal conductivity in the interior volume of the dryer. During the research, to collect data energy consumption and duration of the cloth drying process, we use 3 attempts to test the clothing material, where we observe the temperature and the duration of the drying process. Okay? The energy consumption is measured using the multimeter, and time is measured from start to finish until the samples are completely dry. So as you can see at the small video down at the bottom of the slide, a thermometer and a humidity sensor are placed inside the drying housing to monitor the temperature and humidity level. After the research have been completed, we found out the maximum temperature that can be achieved by this dryer is about 50 degrees Celsius. And the maximum drying time is 60 minutes. Okay. Aside from that, the optimum size of the cabinet is found to be 760 by 600 by 860 millimeters, uh, which allow optimum temperature gain. And of course, the amount of energy used during the operation is up to 250 watts only, maximum. The total time to dry wet cloth in 3 attempts for each type of clothing is within 45 to 60 minutes. Now, this is quite comparable to conventional dryers, which can achieve a drying time of about 30 minutes and a temperature maximum about 60 degrees Celsius. But the power consumption is quite high, which in the range of 1,400 to 1,600 watts per operation. So for conclusion, as the dryer was designed to use low energy, we have a limit usage up to 3 kilograms for the capacity compared to the conventional dryer that uses higher energy. It is around 4 kilogram to 10 kilogram capacity. Finally, the optimum size of the cabinet is 780 by 600 by 860 millimeters in size. The energy consumption is 250 watts maximum, which is allowed to be used in Polytechnic Kuching Sarawak dormitory. So technically, this dryer can be used in the dormitory. And by referring to the previous table, it can be seen that with the help of a twin suction fan for air regulation and an internal reflective aluminum wrap to amplify heat radiation, the working temperature ranges from 40 degrees Celsius to 50 degrees Celsius. And the total time taken to dry wet cloth in 3 attempts for each cloth is within 45 to 60 minutes. And furthermore, this is an advantage over conventional dryers, which using higher power consumption, which is more than 1,000 watts, although it can achieve a drying time of 30 minutes, the power supply is quite high. Our innovative product can do this within 250 watts of power consumption while achieving the drying time of about 45 to 60 minutes. Thank you for viewing my video presentation. Please see my research in Nricon 2022 for further study. Thank you.